In today's lesson, we'll be looking at CSEC mathematics, statistical and probability concepts. I am Latoya Shiraya.
And I am Karima Mundell Thomas. Let's begin.
For today's lesson, we're just going to go through some CSEC questions. All right, so Karima, here is a question from the CSEC May 2010 paper, right?
Right.
And it says, a class of 24 students threw the cricket ball at sports. The distance thrown by each student was measured to the nearest meter. And the results are shown below. And my first question to you, Karima, is what type of data is this? Discrete or continuous?
Well, Latoya, that's a very interesting question. But when I looked at it, it spoke about the distance thrown by each student and that it was measured. And I remember in one of the previous lessons, we talked about anything that we're measuring, such as height, length, weight, those things would represent continuous data.
Right.
Of note, however, we notice here we're not seeing the in-between values, so to speak. We're not seeing any decimal values, only because it was recorded to the nearest meter.
Right.
But it is continuous.
It is continuous. All right. So the first question says that we should copy and complete the frequency table for the data shown. So we have the data on the right, and we need to complete this table. They would have completed the first 2 rows for us, and we are to complete the other 3 rows. But I'm seeing 20 to 29,
Yes.
30 to 39. What are those?
Those look to be class intervals, but I know we're going to speak some more about that later.
Right.
So I don't really want to jump ahead.
Right.
But since they asked us to complete the frequency table, I'm somebody who absolutely loves patterns.
Right.
And we know that math, has to do with patterns. So if I was given this particular frequency table to complete, I would be looking at these class intervals, and I'm noticing that for the first one, it's 20 to 29.
Right.
So values such as 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29 would fall in this particular class.
Right.
And similarly, the second one, 30 to 39. So I would think, Latoya, that the next class interval would be 40 to 49.
Okay.
And another thing I want to point out, I don't know if we're going to be looking at it in more detail, so let me just drop it right here.
Right.
Because I remember in one of the lessons, and even as you were looking back at the concepts earlier, you mentioned class width.
Yes, I did.
Class width. And if my memory serves me right, we would normally subtract 2 consecutive upper limits or 2 consecutive lower limits. And of course, the boundaries could be used as well.
Right.
So if I'm looking here, if I should subtract 29 from 39, that is giving me a class width of 10.
Right.
So I know that there should be 10 values accounted for in this class interval.
Right.
So I can use that as well to check. So 40 to 49, if we were to, manually check it on our fingers, let's go 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. We would actually have 10 values.
Right.
So,
all right, so what's the next class interval?
well, that's easy. 50 to 59.
And then?
60 to 69.
All right.
Cool.
So in completing our frequency table, what's the next step?
Well, on the right of the table, we're seeing frequency.
Right.
And for those who may have missed, the lessons, let's just clear up what the frequency does or what it tells us. It actually tells us how often how often a particular observation, in this case, a particular distance, is seen in the data. So when I look and I see a frequency of 3, that is saying to me values from 20 to 29, there are 3 of them in the data set.
Right.
So if we were to look through, we would be able to identify
And I'm
3.
seeing them, 22, 23, and 29.
All right, so we have 22, 29, and 23.
Right.
Good. So similarly, for 30 to 39,
There are 5 values.
So we need to figure out how many 40 to 49 are in the data.
All right, so just looking, I'm seeing...
So we have 1, 2 here, 3.
8, 4, I count 8.
5, and those 3.
8.
8.
All right.
And you know, Latoya, I just want to point out quickly that to our students, especially if they would have missed anything in the previous term,
Yes.
that when you're converting or when you're transferring raw data
Yes.
onto or into a frequency table, it is very useful for you to use a
tally chart.
So we haven't used it here, but it's very important. It's useful for you to, as you record each observation, you use your strokes to help you to
And
keep
just to mark
account.
off each value so you don't double count or you don't miss anything.
That's it. That's
All
it.
right, so when we look at the values in the class interval for 50 to 59, there are 6 of them, and then there are 2 values for 60 to 69. But I have a question, Karima. Why did we stop at 60 to 69? Why didn't we create another class interval or just go straight to 100 and round it off?
Well, Latoya, remember that the frequency table is supposed to represent the given data. So if we were to look back at the raw data, we'll notice that the highest value that we had there was actually 63.
Right.
Right? But we couldn't stop at 63 here because remember we would have said that the class width is supposed to be 10. And so we had to go from 60 to 69. But before you move on, I also want to ask something because I noticed now that if we were to count how many values we were given, so I'm going to just do a quick check. I'm seeing 8 values in the row and there are 3 rows. So I know that this is 24.
Right, 8 3 is 24
right,
values.
So whenever we are converting or transferring raw data to the frequency table, we must ensure that we double check the total frequency to ensure that it corresponds with the number of values that we get.
So let's see if...
I think we can do a quick check. 3 added to 5, that's 8. Added to 8, 16. Added to 6, 22.
Added to 2, 24.
Good.
So here is a tip, students. You can sum your frequency values to ensure that the sum of the values you have in your frequency table is the same as the total number of observations or data values within the set.
That's it.
All right. So the next question is, state the lower boundary for the class interval 20 to 29. And I'm seeing a very important word there, boundary.
Boundary. Yes.
What is boundary?
All right, so that's an interesting question as well. And looking on screen, I'm seeing it coming up here that the class boundaries are halfway marks between 2 consecutive class intervals.
Okay.
So I'm just going to randomly select, well, let's use the one that they asked us for. So let's talk about 20 to 29, and we're going to also make a comparison with 30 and 39.
Right.
Now, between 29 or from 29 going up to 30, there's a difference of 1. Yes? And going back to the definition, it says it's the halfway mark between 2 consecutive class intervals.
Right.
So I'm thinking that if from 29 to 30 is a difference of 1, then I would need to go halfway between. So I should take 0.5 more on this 29.
Just being fair.
Yes.
Right.
And that would give me my upper boundary for this class. Yes, because it's at the higher end of the class interval. And here would get the other 0.5. So I'm stepping it down to 29.5.
Which is the same. So I'm seeing a correlation there. I'm seeing where if the upper boundary for the 20 to 29 class interval is 29.9, 0.5, sorry, 0.5 or 29 and a half. And then the lower boundary for the 30 to 39 is also 29 and a half or 29.5. Okay, so the upper boundary and the lower boundary for 2 consecutive class intervals are
They
the same.
correspond, right? So the upper boundary for a class interval becomes automatically the lower boundary for the next class interval.
Right.
So let's apply that now, because they asked us to state the lower boundary for the class interval 20 to 29. So going back to this, we just discovered that for the lower boundary, we would step it down
halfway,
0.5,
right,
which means that our lower class boundary would be 19.5 or 19 and a half.
All right. Great.
And there goes our answer on screen.
19 and a half. All right. The next question says, determine the number of students who threw the ball a distance recorded as 50 meters or more.
A lot of times students struggle with this, the or more, 50 meters or more. What does that really mean?
Okay, so I'm thinking if it's 50 or more, we're looking at 50, 51, 52, 53, 60 something, 70 something.
So
any number
that
greater than 50.
Greater than or equal to
50.
Because it did say 50 meters or more.
Right.
So let's just jump to our table quickly. And I'm seeing here that 6 students threw the ball between from 50 to 59 meters. So they would fall in the category.
Right.
And those also who scored 60 to 69 meters would also fall in that category. So I'm thinking we should find the sum of 6 and 2 in order to figure that out. Am I correct?
You are. And so we would have 8 students who would have thrown a distance recorded as 50 meters or more.
Or more. That's it.
All right. And we would have completed 1 question.
Beautiful.
So if you at home was able to complete the question with us, you're already on your way. That's 1 question for you for the CSEC paper.
That's right.
All right. Our next question comes from the May 2013 CSEC paper, and it reads, the scores obtained by 100 children in a competition are summarized in the table below. All right. So here we have the table, a little incompleted, and the first question is to state the modal class interval.
Modal.
Yeah.
Sounds like that's coming from mode. And
yes.
If my memory serves me right, the mode is the observation that has the highest frequency or the one that occurs the most.
Right. So naturally.
All right. So then,
the modal class then refers to the class interval with the highest frequency.
All right, cool. So let me run down the frequency part and look for the highest frequency. All right, I'm seeing 25 as the highest frequency there. Should I write 25 as my answer?
What the question asks us, the modal class interval, and not what is the highest frequency. And that is also an error that the students make. So students, you want to pay much attention to what the question asks you.
Makes sense.
Right?
Makes
so
sense.
in this case, it is asking for the modal class interval and not just the mode, right?
And not the highest frequency.
And not
so
the
they're asking
highest
for the
frequency,
mode,
right.
So therefore, I would say that the modal class then would be 20 to 29. Yeah, it scores. I was about to say meter, but I remember it's another question.
Okay.
All right. So we would have spoken about the class intervals earlier.
Yes, we would have. All right. Then the next question asks us to state the class interval in which a score of 19.4 or 19 4/10 would lie. So you're looking for the class interval, because remember, this is a competition of some scores, and of course we say that our class intervals would include fractional values.
Yeah, because this again is a continuous data.
Right? And so it is asking us which of these class intervals would a score of 19.4 lie.
Now I'm having a problem, Latoya, because when I'm looking at this, I look at the second class interval and it says 10 to 19.
Right.
And I looked at the third class interval and it says 20 to 29.
So which one?
So in my mind, I can't find where 19.4 would lie.
All right, but remember previously you said that the class boundary, thinking about the class boundary, and remember that each class interval is halfway before or halfway after, right? So what would be the class boundary for the class interval 10 to 19?
All right, so the lower boundary would be 9.5 and the upper boundary would be 19.5.
Right, so all right, so we have a 19 point something now.
Yes.
So 19.4 would fall in which?
In the class 10 to 19.
Right.
Yes, because the boundary goes up to 19.5.
Precisely.
Oh, I get it. I don't know how I could have forgotten. So students, please remember that continuous data, yes, it can take decimal values, and so you have to account for the boundaries when you're deciding which class interval a particular score falls. All right, let's go.
Then the next question asks us to complete the table and then calculate the mean score.
All right.
So we have a section that's for class midpoint, and that's incomplete, and I'm seeing a section f times x or f multiplied by x, which is also incomplete. So I'm thinking let's start with the class midpoint first, but what is the class midpoint?
Very interesting question. And we know midpoint, middle, halfway. So I'm seeing a divide by 2 coming out somewhere in there. So let's check what we have here.
So the class midpoint is actually halfway each class interval, and we can find that value. You can simply write out all the values and then determine. But for quick and ease, you know, you can sum the lower class limit and the upper class limit and divide by 2. Or you can also sum the lower class boundary and the upper class boundary and divide that by 2. Finding the mean, so to speak, of the
class interval.
The limit or the boundaries.
Okay, fair enough. So let's check then. So for the class interval 20 to 29, Jacqueline, if I understand, you're saying I should add 20 to 29.
20 or 20 plus 29.
Yes, so we're adding 20 to 29. Yeah, adding 20 along with 29.
Yes.
And then the result, we're going to be dividing that by 2.
Right.
All right, cool. So that's 49 divided by 2. That sounds like 24.5 or 24 and 5/10.
Yes.
All right, beautiful.
All right.
Now, I'm seeing a pattern, Latoya. Fix me up here. Because I'm looking at the class midpoint so far, and I'm seeing 4.5, 14.5, 24.5. It seems to be increasing by 10 each time. Is there any significance?
I want to tell you something. It is said that the difference between 2 consecutive class midpoints must be the same as the class width.
Oh.
So let's check and see what is our class width.
Yeah, we spoke earlier about width, and we said we could subtract, for example, the lower limit for a class here. So let's talk about this one. We are looking at the second class interval and the third one.
Right.
So we can subtract 10 from 20, and that will give us the class width. And that looks like a class width of 10.
Okay, and then let's subtract 2 consecutive class midpoints and see if we'll get 10.
Yeah, man, but I already pointed that out, right?
Sorry. All right.
Right,
so
we're
that
on
means
the same
that we're increasing by 10 each time.
So
students at home, you can determine what your class width is for your class intervals, and you increase your midpoint by 10. Or if the class width for
is 10.
that particular class width, it won't always be 10, so you have to take your questions in its entirety. Or you can sum the limits or the boundaries and divide by 2, whichever method works for you.
All right, and it's good when you know 2 methods because you can always double check.
Right.
Use one to check the other. All right, so I think we can fill in the others. Right. So we have 24.5, 34.5, 44.5, and 54.5.
All right, then we are going to complete the final column, which is just simply multiplication.
Right.
We can see what F represents, which is the frequency, and our X values will be our class midpoint. So you just put that in your calculator or do it manually, whichever suits you, and just complete.
Remember, this is CSEC exam. You want to be quick and accurate. So let's use our calculators for now.
All right. So when you would have used your calculators and get your values, you should get these values. and then you will just sum all your values, which would give you 3,140. Now, the next question asks us to calculate the mean score. Mean score, what's that?
Now, I remember when the data is raw, when we find in our mean, which is, you know, one of the averages that tell us about central tendency in statistics. Now, when we talk about the mean, we usually add up all the values that we get, and then we divide that answer by the number of values that we had.
It's no different.
I'm looking here and I'm seeing that based on the frequency, the total number of values that we have is 100.
Right.
But we don't have the raw data. But I noticed something, Latoya, because my frequency multiplied by X is actually giving me some additions, the result for sections, the sum of sections of the data.
Right.
So this 36 would be the sum for all the scores between 0 or from 0 to 9.
Right.
And we're using the class midpoint here, and we'll speak a little bit more about that later.
Right.
So 188.5 would be the sum for the set of values in this section of our table. Similarly for the others. So if I want an overall total now of all 100 scores, then I can simply find the sum of my F multiplied by X column.
Definitely. But I just want to zoom in a little bit on why the use of the class midpoint and what is the purpose of the F multiplied by X column. As you would have rightly said, for example, 36 would represent all the values from 0 to 9.
Yeah, the sum.
Right? So we don't know what those values are. And the purpose of the class midpoint is to find a value to represent that class interval. So for the first class interval, we are using 4.5 to represent the first class interval. Likewise, 14.5 to represent the second class interval.
I think we're going to speak a little bit more on that.
Right.
In the next question. But let us see if we can get to what the mean is actually. So we have our sum of F multiplied by X, that's 3,140. And of course, we know we need to divide that now by 100. And our mean score is 31.4 or 31 4/10. The question asked us to explain why the value of the mean obtained is only an estimate of the true mean. I wonder if any of our students thought of that.
I don't know.
Well, let me share with you what I'm thinking. So earlier you were hinting at it. So when I look at it, the scores, for example, 0 to 9, there's no way I can know what the exact scores are from this table because I do not have the raw data. Right? So it's a possibility that all 8 students scored 9.
Or 0.
Or 0. We're really not sure, yeah? But what we have done is to estimate by using the midpoint. So we kind of put ourselves in the middle to play it safe, you know? So, you know, we might have some greater than, some less than.
Or some right on the ball.
Or some right on the ball. So we have taken an estimate pretty much of the score. So we used 4.5. And as a result of that, the total that we have here of 3,140 is not going to be a true total, an exact total. So it now becomes an estimate of the total. And that's the reason the mean that we obtained is not the true value, but an estimate.
Because we don't know.
Yeah.
Basically.
You want to add anything?
No. Good. All right. Then I think this is the final question for this question on the CSEC 2013 paper.
Right. So the final part. Yeah.
Final part, right? It asks, in order to qualify for the next round of the competition, a student must score at least 40 points. What is the probability that a student selected at random qualifies for the next round?
Now, Latoya, I'm looking at this question and I see again a term that students struggle with, at least 40.
Right.
What does that mean?
at least 40. So you can't get anything less than 40.
So 40 is the least that you can get.
So if you got a score of 39, 38, 37, 20 something, can't qualify. But if you got a score of 40, 41, 42, 50 something, 60 something, then you are qualified for the next round. So the smallest value that you can get in the competition would have been 40. Anything below that, sorry, you can't make it to the next round.
Okay, so we're looking for values greater than or equal to 40. All right. Now, also the question, so let's see if we can find those first, and then we touch on the probability part.
All righty.
So looking at the table, we're choosing those students who scored 40 or more, which means these 20 students right here, or children, these 20 would meet the criteria.
Right.
Sure, yeah, man, they meet it, them qualify. What about these 12 here?
Well, according to what the rule says, it's or more, 40
so they qualify.
Or more. So they are in the or more.
So how many students we have qualifying then?
20 plus 12, let's have the bigger number.
20. All right, so we had 32. I'm just going to cut her off right there.
All right.
32 students that qualified. Now, how does that affect the probability? Now, when we talk about the theoretical probability,
which it's asking us to find.
Right, because we haven't actually picked the students or did any experiment, yes? So we're looking at the theoretical probability. We need to know the number of favorable outcomes. And that needs to be divided by the total number of possible outcomes. So you might be wondering, favorable outcome?
Possible outcome?
Possible outcome, yeah. In layman terms, the favorable outcome is what we're looking for based on the question.
What we want.
What we want. Mm-hmm. So we're looking for those students who score 40 or more. So that now becomes, those students would represent our favorable outcome. So we said that's 32.
Right.
And total number of possible outcome.
Not the students in your class or in your community.
How many students or children participated in this?
The 100 children in the question.
That's right. And you know, Latoya, this is an error that our students make a lot.
Yes.
When they see probability, they do go to the table and they do get the 32, but they just dropped it on the paper like that. Mm-hmm. So our students, just a reminder, remember now that probability lies between zero. Well, it can be 0, so it's from 0 to 1. All right? So if it's not 0 and it's not 1, then the responses in between would have to be proper fractions, correct?
Some proper fractional value. Or decimal. Right.
All right. So then we can say that our probability here would be, as you rightly have on screen, 20 added to 12, and all of that is divided by 100. So that's 32 out of 100. And of course, you are free to simplify this fraction as well.
But if I can recall, the question says to leave it as a fraction.
Yes, man, but simplifying a fraction is still a fraction.
No, sorry, I thought you said decimal. My bad. My bad.
So you can simplify the fraction, all right?
All right.
And we can move on to question 3.
Look at us.
Oh, my.
All right, so that means you would have completed 2 questions thus far.
Nice.
I hope you are working with us at home. If you are, comment below on our YouTube page if you are on there, okay? All right. The cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 different vehicles is shown below. So they already gave us the table, but I'm seeing a new word here now.
I was just looking at it.
Cumulative frequency. What's that?
Well, you know, as much as I teach math, kind of have one little English streak. So when I hear cumulative, I think accumulate. I think, you know, you're adding on or you're building up, or, you know.
Okay.
So I'm thinking that cumulative, oh, there you go. Cumulative frequency tells the total of a frequency and all frequencies so far in a frequency distribution.
Stop right there. I want you to say it again slowly.
So the cumulative frequency, it's going to tell us that particular frequency and all the frequencies so far in a frequency distribution.
Very important.
So let's see what that means as it relates to this particular table. All right, so another way of putting it, it's the running total of the frequency. And as I would have said, we're adding on each time. So let's ensure that we can interpret this table, Latoya, because failure to correctly interpret this table is going to cause major problems for our students, major errors. So let's talk about this 24. So we're seeing here that 24 vehicles needed 11 to 20 liters of petrol, correct? Then we're told that 59 vehicles, that's a cumulative frequency now.
Right.
So this does not mean that these 59 vehicles are only for this class interval.
But according to the definition, so far...
Good. So this 59 would be speaking about vehicles that needed from 11 to 30 liters of petrol.
Right.
In other words, these 24 vehicles are included in the 59.
Right.
Yes. And if we take it a step further, we have 101 vehicles here.
Right.
And though that 101 is representing vehicles requiring 40 liters
or
less, all the way back to the 11 there.
So that 101 value takes into consideration the 59, and the 24.
Which the 59 already had the 24, so we don't even have to go that far back.
So what it is saying is, so far, I want us to understand that so far we have vehicles that require 40 or less liters of gas.
And that's 101 vehicles in all so far.
So far. All right.
Good.
So let's see what the question actually asks.
Just want to point out one little thing before you go to the question. When I get to this 150 at the end of the cumulative frequency column, what will that tell me?
So far, everything. Everybody.
Beautiful.
Total.
Good.
Sum.
All right.
Okay.
So if we look back at the question, it mentioned that there were 150 different vehicles in this particular survey.
Right.
All right. And if we look at our cumulative frequency, because we kept adding on, by the time we get to our last class interval, the cumulative frequency should correspond with the total number of vehicles in this case that were in the survey.
So that's a point to note again, students. If your final value for your cumulative frequency column is not the same as the number of data points or data set, then you know you have an error and you need to go and recalculate.
That's it.
Right? All right. So the first question asks us, simple, determine the lower class boundary. And we already know what the class boundary is.
Yes, we did that
for the class interval 21 to 30, and that would be
20.5. That's right. We took off 0.5, yeah?
Right.
Beautiful.
All right. And then the other question asks us, what's the class width? Simple.
And we touched this already as well, many times. So we spoke about the class width. We should subtract, for example, upper limit 1 from upper limit 2. So in this case, 20 taken from 30? 10. And students, don't assume that it's always 10. These questions just happen to be 10.
Don't remember that the ladies on the TV telling you it's 10, you know.
I know, right?
Don't tell any lies on us.
All right.
All right. How many vehicles were recorded in the class 31 to 40?
So, Latoya, if my memory serves me right, we just spoke about that.
We did.
And we said that this 101 here is representing all the vehicles requiring 40 liters of petrol or less. So this 101 takes in all the vehicles that came before this class interval as well. So in other words, the 101 included the 59 vehicles that were before.
Right.
So if I want to know just the vehicles in this particular class interval, I feel in a subtraction coming.
You feel it?
Yes.
I feel it too.
All right. So we need to take that 59 out of the 101 and we will know that there are 42 vehicles that required 31 to 40 liters of petrol.
Alrighty. Okay, next question. A vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 or 50.5 liters of gas?
All right, so more than means that it's not equal to, but greater than only. So we're looking for the number of vehicles that required greater than 50.5 liters of petrol.
But I'm not seeing a 50.5 on the...
But Latoya, you corrected me in the previous question, you know.
I did?
Yes, you did. And you reminded me about boundaries. Yes, so let's jump to that last class interval because that seems to be in my mind where we are. But let's double check. What's the lower boundary for this class interval?
50.5.
Which means all the vehicles that required more than 50.5 liters of petrol.
Is that 150?
No.
Oh.
Would fall in this class interval.
Okay.
So now we need to figure out how many vehicles are right here.
All right.
So we talked earlier about the running total and it being added.
Yes, we did.
And we know that this 150 included the 129. So we need to take those out to see how many are in this specific class interval.
Right. All right.
And that looks like 21. And now we talk about the probability. Let's hit it home again because probability we said from 0 to 1, and so any in between would have to be proper fractions. So though we had 21, we must account for the total number of possible outcomes, which was 150.
Indeed.
So it's 21 out of 150, or divided by.
All right. Then the other question said that Byron estimates the median amount of petrol to be 43.5 liters. Explain why Byron's estimate is incorrect. But before I'm going to even address Byron, I need to know what median. What's that?
Median. A sense in a middle coming. Yes. So the median is the middle value of a data set that is sorted.
Right.
Yes. So when
we say sorted, what do we mean?
So the values are arranged either in ascending order, meaning from smallest to largest value, or it could be from, in descending, which would be from largest to smallest value. Now, when it comes to the table, if we look at the volumes, it's already arranged for us.
Yes.
So think about 150 values.
All right,
and we
so
want to find
the middle value.
Yep.
So if I have 150 and I want to find the middle, means that I'm going to split the data in two. Half and half.
All right.
Right, so I can just simply divide by 2.
But hold on. If I divide 150 by 2, 150 by 2 is going to give me 75. Are you saying that the median is the 75th?
No, I'm saying that I'm dividing my group or my data set into 2 halves. So that means that I have 75 on one side and 75 values on the other side, which means that if I have the 75th value from the first set, and then I'm looking at the 76th value, which would be in the second set, and I'm looking right in between there, so there's a difference of 1. So that means that is about the 75.
So we're looking at the position 75.5 pretty much. So we're looking for the median halfway between the 75th
and the 76th
observation.
Right.
Now, there's something interesting about cumulative frequency.
Right.
Because it actually helps us with positions.
Yes.
So when I look at this 24, I know that this class interval ended with the 24th vehicle.
Right.
And then when I look at the second class interval, that 59, because it's cumulative, it ends with the 59th vehicle.
Right.
We reached the middle yet?
No,
because we're looking
for 70 something.
75, halfway
0.5,
between. All
right?
So when I look at the third class interval, we're going to the
101st vehicle, which means that clearly
we're past the middle.
we're past the middle.
So where would the middle fall, Latoya?
Definitely here, because we're looking for the 75th and the 76th vehicle.
Right.
And that would
and
fall
they both
in,
fall here.
right.
So
what did Byron say?
43.5, Byron said.
But that would have been in the other class interval.
So Byron, we're past the median. And
Gone.
So Byron's estimate is indeed incorrect.
All right. Great. Okay, and we're on to the fourth question.
Oh, nice.
Nice. So we would have completed 3 questions. If you've gotten any of those questions or similar, you should be able to complete.
That's right.
All right, so question 4, and
this
this was taken from the 2016 May CSEC paper. The table below shows how the minutes taken by all students to complete a science experiment were recorded and grouped.
Hold on, okay.
And these are the questions. Complete the table and on a grid paper using the scale of 1 centimeter to represent 5 minutes on the x-axis, 1 centimeter to represent 5 students on the y-axis. Draw a cumulative frequency curve. So let's go back to our table and we need to complete. I'm hoping that you were trying and you completed your table and you would have at least drawn your Cartesian plane. This is what your table should look like if you completed. If you haven't, write it off quickly, right?
So remember, the cumulative frequency is simply adding each frequency as we go along.
So just to quickly go through, so our first column would have 1 and then we're adding the first row. Then we're adding 1 added to 2 or 2 added to 1, which gives us 3. 5 added to or 3, which gives us 8. 7 added to 8, which gives us 15. 10 added to 15, which gives 25. 15 added to 25, which gives 40. 8 added to 40 gives 48. And 2 added to 48, which gives 50.
All right, so if we were asked how many students participated in this particular survey, we know it would be 50.
50. Then the next part of the question, the other part of the question asks us to complete our
cumulative frequency curve.
Right, thank you very much. I don't know. It then said that you should use 1 centimeter on your x-axis to represent time.
All right, and so 5 minutes.
For 5 minutes, and then we have 1 minute representing 5 students
1
on
centimeter.
What am I saying? 1 centimeter representing 5 students on the y-axis.
All right, cool. So when we talk about the cumulative frequency curve, we're actually using our upper limits and our cumulative frequency to plot the points on our Cartesian plane. So let's put in our points quickly, Latoya, as we zoom in on screen.
So we're
mapping 5 minutes with 1 student, right?
Right.
10 with 3, and continue 15 with 8, 20 with 15, 25 to 25, 30 to 40, 35 to 48, and 40 mapping to 50.
And
I do hope that they were able to get this part.
Right, and remember when we're drawing our cumulative frequency curve, you want to use your free hand. It's not a straight line, and you want to take your time and connect the points, and it would give you a nice little curve looking like this.
Beautiful. Let's see what else this question asks for.
Okay, it then says to use the graph. Use the who?
The graph.
Use the who?
Graph.
All right, choir. And estimate the median time taken to complete the experiment, the interquartile range, and the probability that a student chosen at random took 30 minutes or less to complete the experiment. Using our what?
Graph.
All right, not your calculation, not your table. Using your?
Graph.
Okay, all right.
So let's talk about the median. We already spoke about how to identify where the median is. So in this particular data, we had 50 students.
Right.
And so if I was to split this data in half, it would be 25 on this side, 25 on this side. So my median position would be halfway between the 25th and the 26th observation. So on my graph then, I need to look for 25.5 on my vertical axis. That's right where cumulative frequency is.
Okay.
And once I've found that point, then I'm going to take my ruler and draw a broken line until it gets to the curve, and then I continue downward now to read off the value.
All right. And then when we would have find our point, our reading off, we go straight down. And that means that the median time taken to complete the experiment would be
approximately 25 minutes.
Right, approximately.
And note, students, where did we get the median, the reading from? Down where the time is. So it's 25 minutes. Let's see if we can do some more before.
All right, we want to also estimate the interquartile range.
So if I'm talking about interquartile, that sounds like quarter. So I'm thinking about some quartiles. So let me get to the board quickly. So if we were to have our data arranged in this format, our median is also known as Q2.
Right.
And so we're looking for a value that cuts off the bottom quarter of the data, and I'm also looking for a value that cuts off the top quarter of the data. So if the median was located at this position, halfway between the 25th and the 26th,
yes,
then my quarter is going to be halfway
in between that first half.
Right, so I can simply have 25.5, and that could give me 12.75. In other words, it's not halfway, but it is between the 12th and the 13th observation.
Right.
So I think we can look back on our graph now. We find 12.75 on the cumulative frequency part, and of course we read off our value on the horizontal axis, and that value looks like
approximately 18.5 minutes.
I remember this is an approximation. Now, how could we find, coming back to location again, so this is our lower quartile we have found, Q1.
Right.
And now we want to find the upper quartile, which is Q3. So this is taking us 3/4 way.
Right.
So if I want to find this location, I could simply take this 12.75, which is a quarter way, and multiply that by 3. And this will actually take us to 38.25, and that particular position is between the 38th and the 39th observation.
Which will give us a value of 29 and 29 minutes. Now to find the interquartile range, you will simply subtract Q1 from Q3,
yes,
which would give us an approximation of 10.5 minutes.
Beautiful.
Now, the final question would have asked us to find the probability that a student chosen at random took 30 minutes or less to complete the experiment, which is just using the graph again. And you would...
Just want to point out quickly, Latoya, that 30 minutes, remember now, we're given the 30 minutes, so we must be finding that 30 on the time axis. That's our horizontal
minutes
axis, and then we map up. So that was 40 students, and we need to account for the total possible outcomes. So that's 40 out of 50.